Space is not as silent as it seems. Whispers from the darkness sometimes reach us, carried on the backs of cosmic wanderers from other star systems. These interstellar comets are more than just frozen travelers. They are messengers, and some of the signals they emit defy all our expectations. You are about to uncover 25 of the most bewildering cosmic puzzles that challenge everything we know. We will explore an object that accelerated without explanation, and a radio whisper that perfectly matched a comet's path but sounded entirely artificial. What do you think it means when the universe sends us a signal we cannot understand? It arrived without warning, a silent speck against the vast ocean of stars. In October 2017, astronomers in Hawaii spotted something unprecedented, the first confirmed visitor from another star system. They named it Oumuamua, a Hawaiian word for scout. This was no ordinary comet. Its shape was bizarre, a pancake or a cigar tumbling end over end through our solar system. But the true mystery began as it was leaving. Oumuamua started to accelerate, not from gravity. The sun's pull was fading behind it. This was a non-gravitational acceleration, a push from an unknown force. The scientific community scrambled for an answer. The most conventional explanation was outgassing. Just as a comet vents gas and dust when heated by the sun, creating a visible tail, perhaps Oumuamua was doing the same. But there was a problem. Our most powerful telescopes saw no tail, no cloud of gas or dust, no signature of water or carbon dioxide, nothing at all. How could outgassing be strong enough to push the object without leaving a single trace? This absence of evidence opened the door to more exotic ideas. Could the acceleration be from solar radiation pressure, effectively using sunlight as a sail? For that to work, Oumuamua would need to be incredibly thin and light, a sheet of material unlike any natural object we have ever seen. The debate divided astronomers. One side insisted it must be a rare but natural type of icy body with strange properties. The other wondered if we were seeing something else entirely, a relic of alien technology, a solar sail from a distant civilization. The scout passed by too quickly for us to ever know for sure, leaving behind a single, haunting question. What if the first messenger we ever caught was trying to tell us something we simply could not comprehend? Just 2 years after Oumuamua's mysterious departure, the universe sent us another visitor. This one was different. Discovered by an amateur astronomer named Gennady Borisov, the comet now bearing his name looked exactly as a comet should. It had a brilliant tail of gas and dust, a classic frozen heart warming as it approached the sun. Scientists were thrilled. Here was a second chance to study an object from another star, one that behaved more predictably than the strange, silent scout that came before. They pointed every available telescope at Borisov, listening and watching with all the technology at our disposal. But this comet too held a surprise. Amidst the expected data, some observatories detected a faint, persistent whisper, a radio signal that was not supposed to be there. Radio emissions from comets are not unusual in themselves. As the sun heats a comet, it ionizes the gas in its coma, creating a cloud of charged particles that can generate low-level radio noise. It is a natural, chaotic crackle. The signal from Borisov was different. It was a faint, narrowband whisper, a tone that seemed too clean and too steady to be a product of simple natural processes. It did not match the typical broad-spectrum emissions of a comet's chaotic atmosphere. Researchers were left scratching their heads. What could produce such a coherent signal from a simple ball of ice and rock? The composition of Borisov itself was already a puzzle. Analysis showed it contained unusually high amounts of carbon monoxide, suggesting it formed in a very cold, distant region around its home star. This bizarre chemistry painted a picture of an alien solar system very different from our own. Was this strange signal somehow a product of that exotic environment, a natural phenomenon we had never witnessed before? Or were we hearing something else, a faint beacon that had hitched a ride on this icy traveler? The whisper from Borisov was never strong enough to confirm, leaving behind the unsettling possibility that even the most familiar-looking messengers can carry secrets we are not equipped to hear. Deep within the vast archive of sky surveys, a different kind of mystery was waiting to be uncovered. The Lincoln Near-Earth Asteroid Research Program, known as LINEAR, scans the heavens with one primary goal: to find asteroids that might one day approach our world. In 2009, its automated telescopes recorded something that defied this simple purpose. An object catalogued as a routine near-Earth asteroid suddenly erupted, flaring to hundreds of times its normal brightness in an incredible, violent outburst. This was not a slow brightening, it was a cosmic detonation. For a brief, spectacular moment, this speck of rock became a brilliant beacon in the dark. Accompanying this visual flash was a burst of complex radio noise, a chaotic shriek across multiple frequencies that saturated receivers. At first, astronomers believed they were witnessing a catastrophic collision, perhaps two asteroids smashing together in a cloud of dust and debris. Yet the more they analyzed the data, the less this explanation held. The object's path, traced backward, seemed to originate from deep interstellar space. It was not a local citizen of our solar system at all, but another visitor merely passing through. This realization transformed the event entirely. The flare was not a collision, it was most likely a massive outgassing event. Imagine a deep frozen iceberg forged in the cold of another star, suddenly plunging into the relative warmth of our inner solar system. Stresses fracture its core, and volatile ices trapped for eons flash directly into gas, ripping the object apart in a single, spectacular eruption. This was not the gentle, continuous venting of a comet like Borisov, but a singular, apocalyptic release. The radio emissions were the signature of this explosive transformation, the sound of charged particles screaming away from the disintegrating body. This interstellar comet had been hiding in plain sight, masquerading as a harmless asteroid until the sun triggered its final, glorious act of self-destruction. It forces us to wonder how many other silent wanderers are out there, their true natures hidden, only revealing themselves in a fleeting, final shout. The deep silence of space is broken only by the echoes of our own searching. For decades, one signal has stood above all others as a monument to our cosmic curiosity. In August 1977, a radio telescope in Ohio picked up a burst of such intensity and peculiarity that the astronomer who saw the printout simply circled the string of numbers and wrote one word beside it: "Wow." The signal was powerful, narrowband, and lasted for 72 seconds, precisely the duration you would expect from a fixed telescope as a point source moves across its field of view. It was never heard again. For over 40 years, the WOW signal remained the ultimate cold case, a perfect candidate for an artificial transmission with no identifiable source. Then a radical new hypothesis emerged. An astronomer proposed that the signal's origin point in the constellation Sagittarius could be traced backward. His calculations suggested something astonishing, that in 1977, the path of an undiscovered interstellar object, a comet from deep space, would have been passing directly through that exact patch of sky. This was not a slow-moving asteroid from our own solar system, but a swift traveler from another star, one that would have been completely invisible to our telescopes at the time. The implications are staggering. Could the WOW signal have been a natural but incredibly rare phenomenon generated by this passing comet? The theory suggests that a huge cloud of hydrogen gas surrounding the interstellar visitor could have amplified a background radio signal from a distant quasar, focusing it into that brief, powerful burst we detected. It is a fringe idea, and many scientists remain deeply skeptical, pointing out that we have never observed such an effect from any other comet. Yet the theory persists because it offers a tantalizing, if unproven, answer to a decades-long mystery. It asks us to consider a profound possibility that one of our greatest enigmas was not a message sent, but a message reflected, a cosmic mirror showing us our own hope for contact, bounced off a silent, frozen messenger from the void. The chemistry of a comet is like a fingerprint telling the story of where and how it was born. When comet C 2019 Y4, known as Atlas, first brightened in the sky, it seemed like a promising spectacle, a brilliant visitor that might even become visible to the naked eye. But as telescopes turned toward it, they recorded a chemical fingerprint that made no sense. Its spectral lines, the unique barcodes of light that reveal which molecules are present, showed an alarming and bizarre composition. The ratios were all wrong. It possessed an overabundance of volatile gases like diatomic carbon and cyanogen, molecules that are typically destroyed quickly by sunlight. In a normal solar system comet, these fragile compounds would have been baked away long ago near its parent star. For Atlas to have so much of them, it must have formed in an incredibly cold, dark, and distant region of its own system, a place far more frigid than anything in our own cosmic neighborhood. This was not a composition we had ever seen before. It pointed directly to an alien origin, a visitor forged in the deep freeze of another star. The comet's strange chemistry was a prelude to its fate. Not long after these spectral lines were recorded, Comet Atlas began to fracture, crumbling into a trail of cosmic dust before it could put on its promised show. Its fragile, exotic ices could not withstand the gentle warmth of our sun. The very ingredients that made it a chemical alien also sealed its destruction. This forces a profound question. How many other interstellar wanderers have we missed simply because they were too fragile to survive the journey, disintegrating into nothingness before we could even detect their strange and telling light? Sometimes the most profound signals come from the places we see nothing at all. Across the vast listening posts of our planet, radio astronomers have catalogued a strange phenomenon known as fast radio bursts. These are blasts of immense energy, cosmic shouts that last for mere milliseconds yet release more power than our sun does in days. Many of these bursts come from distant galaxies, their origins tied to collapsing stars or spinning neutron stars. But a handful of them have appeared much closer to home, their points of origin tracing back to what seems like utterly empty space within our own galactic neighborhood. One particular series of these brief, local bursts presented a puzzle that defied conventional explanation. They were incredibly powerful, yet they seemed to come from a void, a patch of sky with no visible star, no galaxy, no discernible source of such energy. How could a blast of radio waves powerful enough to be detected across interstellar distances simply appear from nowhere? A small group of researchers proposed a radical answer. They suggested we might be detecting the signals of a dark comet. This is not a comet like Borisov or Atlas with a shining tail of ice and dust. A dark comet is a hypothetical object, a cinder of rock and ancient, inert material that has been stripped of all its volatile ices over countless eons. It would reflect almost no light, making it nearly impossible to spot with optical telescopes. But as this invisible wanderer moves through space, it still interacts with the environment. The theory suggests that as a dark comet plows through the thin sea of charged particles that fills the void, or if it passes through a powerful magnetic field, it could create a sudden, tremendous burst of radio energy. The object itself would remain dark and unseen, but its passage would be announced by a brilliant, fleeting flash on our radio telescopes. The connection is tenuous, a speculative link between an unexplained signal and an unseen cause. Yet it opens a terrifying and thrilling possibility. What if the void around us is not empty at all, but teeming with these dark, silent travelers? We only notice them on the rare occasions when they scream. The desert sky in California holds a relentless electronic eye, the Zwicky Transient Facility, scanning the heavens for anything that changes. In 2020, it spotted a faint object moving through our solar system, initially catalogued as just another comet. But this one, designated C2023, was different. Its light did not simply brighten and fade like other comets. Instead, it dimmed in a precise, repeating rhythm. This was not the chaotic flicker of outgassing ice, but a steady, periodic pulse, as if something was passing in front of it at regular intervals. Then came the radio data. From the same patch of sky, a separate listening post picked up an incredibly faint signal. It was a whisper of a radio pulse, and it was repeating in perfect time with the comet's dimming. The combination was baffling. A natural comet might brighten erratically, and it might produce chaotic radio noise, but it does not rhythmically dim while simultaneously broadcasting a synchronized, repeating pulse. It was like finding a lighthouse where the lamp flashes in time with the foghorn, a coordination that nature rarely, if ever, produces. What could possibly explain this? One theory suggested a swarm of dust and debris, shaped by some unknown gravitational dance, could be orbiting the nucleus and periodically blocking its light. But that did not account for the clean, repeating radio whisper. Another, more speculative idea wondered if the object itself was not a simple comet, but a derelict piece of machinery, a dormant spacecraft or a broken satellite from another star, with some spinning component that caused both the dimming and the faint automated signal. The ZTF anomaly remains an open case, a whisper of order in the cosmic noise that challenges our most basic assumptions. If a simple comet can mimic the signature of a machine, how will we ever know what is natural and what is not? A ghost was caught on camera by a machine designed to watch the sun. The SOHO spacecraft, a sentinel permanently fixed between Earth and our star, uses a device called a coronagraph to create an artificial eclipse, blocking the sun's blinding face to study its faint outer atmosphere. In this carefully constructed darkness, automated systems log thousands of images, and amidst the expected data, analysts found something that should not have been there. It was a fast-moving blur, a faint blob of light streaking through the coronagraph's field of view. The initial and easiest explanation was to dismiss it as a glitch, a cosmic speck on the lens or a transient artifact in the electronics. After all, the instrument sees countless such anomalies, but this one was different. When researchers later reconstructed its path, they found its trajectory was not like that of a typical sun-grazing comet from our own solar system. Its speed and angle were hyperbolic, suggesting it was not bound by the sun's gravity at all. It was moving too fast on an escape trajectory out of our system. This was not a local object, it was a visitor, an interstellar comet that had flown breathtakingly close to the sun itself. The most puzzling part was its signature. The blob was not the clear, defined coma of a normal comet. It appeared more as a cloud of plasma, a glowing patch of superheated, charged gas. This suggests the object, perhaps a fragile aggregate of ice and dust much like Comet Atlas, did not merely vent gas as it was heated. It may have undergone a catastrophic disruption, vaporizing almost instantly in the solar inferno and creating a temporary, expanding cloud of ionized material that briefly glowed in the coronagraph's eye. The SOHO ghost was never seen again. It vanished from the data as quickly as it appeared, leaving behind only a few frames of evidence and a profound implication. Our most successful sun-watching machine might have accidentally recorded the death scream of an interstellar traveler, a signal of destruction we almost deleted as simple noise. It makes you wonder how many other messengers have we erased, simply because their message did not look the way we expected it to. A signal does not have to be loud to be unsettling. In the serene mountains of West Virginia, the colossal dish of the Green Bank Telescope, the largest steerable radio telescope in the world, listens to the faintest whispers of the cosmos. Its sensitive instruments once recorded a whisper so peculiar it stood out from the cosmic background like a single, pure note played in a room full of static. This was a narrowband radio emission, a signal concentrated into a single, specific frequency. In the language of radio astronomy, that is a red flag. Natural cosmic objects, from swirling galaxies to exploding stars, typically produce broadband noise, a messy cacophony across the entire spectrum. A narrowband signal, by contrast, is efficient and clean. It is the kind of signal you would design if you wanted to send a message across the vast interstellar distances without it being lost in the noise. This particular whisper was traced back to a seemingly empty patch of sky. The mystery only deepened when researchers cross-referenced the location with known celestial traffic. They discovered that the path of a catalogued interstellar object, a small, fast-moving comet from another star system, had passed directly through that same region of space just a short time before the signal was detected. The coincidence was too striking to ignore. Could this pristine radio whisper have been generated by this passing icy wanderer? The scientific hunt for a natural explanation began immediately. Perhaps the comet's cloud of ionized gas, its coma, could have acted like a natural maser, amplifying a random bit of background radiation into a coherent signal. Or maybe an interaction between the comet's magnetic field, if it had one, and the solar wind created a focused burst of energy. The problem was, no model could satisfactorily replicate the signal's precise, narrowband character. We have observed thousands of comets, and none have ever been recorded producing such a clean, artificial-sounding tone. This left a haunting gap in understanding. The Green Bank signal remains a profound enigma, a whisper of order that appeared exactly where a messenger from another star had been. It forces us to confront a deeply unsettling possibility. If we cannot tell the difference between a natural phenomenon and an artificial one, how will we ever recognize a true message when it finally arrives? A different kind of pattern emerged from the dry Arizona air. The Catalina Sky Survey, another automated sentinel scanning for asteroids, locked onto an object that refused to behave. While most comets brighten and fade over days or weeks, this one flickered. Its light would surge and ebb in a matter of minutes, a frantic, erratic pulsing that had no easy explanation. This was not the steady rhythm of a rotating body, but a chaotic stutter, as if the object itself were convulsing. Then came the infrared data, which revealed its own subtle secret. With every erratic brightening in visible light, there was a corresponding, faint pulse of heat. The two signals were locked in a strange, frantic dance. For a natural comet, this was bizarre. A simple outburst of gas and dust would cause a brightening, but the heating would be more gradual and sustained, not this precise, minute-by-minute synchronization. It was as if someone were repeatedly turning a flashlight on and off, and each time the bulb grew briefly warm to the touch. One theory proposed a surface covered in a strange, reflective frost. As the object spun, patches of this super-volatile ice could be turning directly from solid to gas in the sunlight, creating brief, intense jets that flared with light and heat before just as quickly subsiding. Another, more unsettling idea was that the object was a loose rubble pile, a collection of dark boulders and dust held together by the faintest of gravitational embraces. Internal shifts and collapses could be exposing fresh, icy surfaces to the sun in sudden, unpredictable bursts, causing the entire agglomeration to flicker like a dying ember. The Catalina flickerer presents a fundamental challenge. It suggests that some interstellar objects are not monolithic bodies, but dynamic, unstable structures, changing before our very eyes and offering a glimpse into the violent and fragile processes of their formation in a system far, far away. Rotation is a fundamental truth of the cosmos, but the spin of one particular visitor was anything but simple. Discovered by the Pan-STARRS telescope in Hawaii, this interstellar object was tracked for weeks, and astronomers quickly realized it was not spinning smoothly like a thrown football. Instead, it was tumbling end over end in a chaotic, unpredictable wobble, as if it had been violently kicked out of its home system. This complex motion alone suggested a turbulent past, but the real mystery was heard, not seen. As the object tumbled, sensitive radio antennas detected a faint, low-frequency hum that seemed to change in sync with its erratic rotation. The signal would strengthen and fade in a pattern that mirrored the object's clumsy dance through space. Low-frequency radio waves are often associated with magnetic fields. On Earth, our planet's magnetic field interacts with the solar wind to create a constant, low chorus of radio emissions. For this tumbling object to produce such a signal, it would need to possess a surprisingly strong and complex magnetic field of its own. But how could a mere chunk of ice and rock, a presumed leftover from planetary formation, generate such a thing? A simple, homogeneous body would not create this modulating whisper. The signal suggested an uneven interior, perhaps a core rich in metallic minerals or a layered structure with different types of ice and rock, all generating a lopsided magnetic field that revealed itself with every tumble. This was not a simple comet. It behaved more like a colossal, magnetized piece of cosmic shrapnel. The Pan-star's tumbler forces us to reconsider what these travelers are made of. Are they uniform balls of ice, or are they intricate, layered worlds in miniature, carrying the complex magnetic history of their birth within their spinning, chaotic hearts? The next signal only deepens this mystery of what lies beneath the surface. Sometimes the most energetic signals come from the smallest objects. The LOFAR array in Europe is not a single telescope, but a vast, sprawling network of thousands of low-frequency antennas spread across multiple countries. Working in unison, they create a single, gigantic electronic ear, sensitive to the faintest whispers of the radio universe. This network once detected a puzzling signal from a small, fast-moving body on a trajectory that suggested it was just passing through our neighborhood. The emission itself was what scientists call non-thermal. Now, to understand why that is so strange, you need to know the difference. Thermal radio emission is the simple, expected kind. It is the natural radio noise given off by any object that has heat, like the warm static from a rock baking in the sun. Non-thermal emission is something else entirely. It is a far more energetic process, often generated by charged particles like electrons, spiraling at incredible speeds through powerful magnetic fields. We see this kind of intense, structured radio output from the turbulent atmospheres of giant planets like Jupiter, or from the frenetic activity of distant stars. We do not expect it from a small, inert comet nucleus, a frozen rock thought to be little more than a silent, primordial iceberg. For a comet to produce such a signal, its interior or immediate environment must be crackling with unexpected energy. One theory suggests the object could have contained pockets of radioactive material within its core. As these elements decayed, they would have energized the surrounding ice and dust, creating a local source of power that could, in theory, accelerate particles and generate the observed radio whisper. Another, perhaps more plausible, idea involves the Sun. As this interstellar visitor dove closer to our star, the intense solar wind, a relentless stream of charged particles, could have slammed into its surface or its magnetic field. If the comet had even a weak magnetic field of its own, this violent interaction could have acted like a natural particle accelerator, whipping electrons to near light speed and forcing them to emit that coherent radio signal. But this explanation also raises a deeper question. Why have we never detected such a clear, non-thermal signal from the countless local comets in our own solar system that undergo the same solar bombardment? It implies that this visitor was fundamentally different, perhaps with a unique magnetic or chemical composition that made it resonate like a bell when struck by the solar wind. This small, fast-moving body was not the inert fossil we expected. It was a dynamic, energetic entity hiding a secret source of power within its icy heart, a power that only revealed itself as a ghostly radio echo in the most sensitive ears on Earth. Even a celebrated comet can hide a strange secret in its song. In the summer of 2020, Comet Neowise put on a dazzling display, a brilliant streak of dust and ice visible across the globe. It was a familiar visitor from our own solar system's outer reaches, a beautiful but local phenomenon. Yet when some researchers analyzed the radio signals it emitted, they claimed to find something that defied simple explanation. Amidst the expected chaotic hiss of the comet's interaction with the solar wind, there were subtle, repeating fluctuations. The pattern was not random noise, but a complex sequence of peaks and dips that some described as almost melodic, a rhythmic cadence buried within the static. This fringe analysis suggested the comet was not just hissing, but singing a structured song. Mainstream science was swift and firm in its dismissal. The apparent melody, they argued, was a classic case of apophenia, the human brain's innate tendency to find meaningful patterns in random data. We hear a face in the static of a television, we see a shape in the clouds, and we can just as easily hear a song in the natural, complex radio emissions of a plasmoid tail. The scientific consensus held that the fluctuations were simply the result of turbulent magnetic fields and the chaotic breakup of ionized gas clouds, a natural symphony of disorder. But the idea of the singing comet captured the public imagination and refuses to fade. It speaks to a deeper question that haunts our search for cosmic signals. When we listen to the universe, are we truly hearing what is there, or are we, in our profound loneliness, simply listening for a voice that sounds like our own? This tension between the cold data and our warm interpretation is the very heart of the mystery, a reminder that the most powerful signal of all might be the human desire to hear one. The cold void between stars is a place of profound stillness where temperatures hover just above absolute zero. At such extremes, water ice should be as stable as stone, clinging to the surface of any wandering body for eons. Yet data from the powerful Gemini Observatory presented a paradox that challenged this basic truth. Astronomers had turned its infrared eye toward a faint, fast-moving speck believed to be an interstellar traveler, and the spectra it returned were baffling. They showed the clear, unmistakable signature of water ice, but the object was already far too distant from any star for simple solar heating to explain its activity. At its current location, the feeble starlight should have been utterly powerless, leaving the object frozen solid and silent. The ice should not have been detectable at all. It should have long since vanished into the vacuum. So why was it still there, shining its spectral signature into the Gemini telescope? One possibility is that this visitor possessed a unique, super-resilient form of ice, perhaps mixed with dark, complex organic compounds that formed an insulating crust. This shell could have trapped volatile ices deep within, allowing them to slowly seep out through cracks long after the sun's warmth had faded to a distant memory. Another, more radical, theory suggests the object was not entirely inert. It might have harbored a tiny internal heat source, perhaps from the slow decay of radioactive elements trapped in its core since the formation of its home system. This faint, internal radiance could have been just enough to sustain a whisper-thin atmosphere of water vapor, a private, miniature greenhouse effect playing out within the heart of a lonely iceberg. This was not a comet as we understand them, a body that only wakes when kissed by a star's light. This was an object that carried its own warmth, a self-sufficient wanderer steaming gently in the dark. It makes you wonder if we have been fundamentally mistaken about the nature of these travelers. What if some are not frozen corpses but dormant worlds, holding onto the faint embers of their creation as they journey forever through the night? Before its tragic collapse, the great Arecibo dish was more than an icon. It was a listening ear pressed against the cosmos. In its final years of operation, it performed a routine radar study of a small, fast-moving object passing through our solar system. This was standard practice, bouncing radio waves off a celestial body to learn about its size, shape, and composition. But the echo that returned was anything but standard. The radar data revealed a surface with an unusually high metal content. For a typical comet, this was an anomaly bordering on the impossible. Comets are famously dubbed dirty snowballs, composed primarily of ices, dust, and rocky rubble. Metal, especially in the concentrations Arecibo seemed to detect, is a material we associate with asteroids, the baked and rocky leftovers from the inner solar system. This object appeared to be a hybrid, a paradoxical snowball wrapped in a metallic shell. The data pointed to a surface potentially rich in iron or nickel, a gleaming, reflective coat on what should have been a dark, sooty iceberg. How could such an object form? One theory suggests a catastrophic collision in its home system. Imagine two bodies slamming together, a metallic asteroid and an icy comet, their debris fusing into a single conglomerate object that was then flung into the void. Another, more tranquil idea proposes a slow, gravitational dance in a young planetary system, where metal-rich dust from the inner regions was gently swept out and incorporated into the forming comets in the cold outer reaches. But neither explanation fully satisfied the scientists who studied the data. The signal was a ghost in the machine, a single, puzzling data point from a telescope that is now silent. With Arecibo gone, we lost the one instrument capable of performing a follow-up study, of sending another pulse of energy to confirm or deny the strange metallic echo. The object itself is long gone, continuing its endless journey between the stars. It leaves us with a haunting legacy, a question etched into the static of an old data tape. Were we looking at a cosmic rarity, a freak of nature, or is this metallic sheen a more common feature of interstellar travelers, a hidden signature we have only just begun to glimpse? Even the deepest portraits of the cosmos can hide a fleeting secret. When astronomers pointed the Hubble Space Telescope at a seemingly empty patch of sky for the famous Deep Field image, they were attempting to stare into the furthest reaches of the universe. The resulting mosaic revealed thousands of ancient galaxies, a stunning vista of cosmic history. But tucked away in one corner of this monumental image was a tiny, unexpected detail, a faint, streaking object that was not a distant galaxy at all. It was moving and it was close. Analysis revealed it was an interstellar comet captured by pure chance as it traversed Hubble's field of view. Its trail was not the bright, distinct tail of a local comet, but a faint, ethereal glow, a wisp of dust and gas illuminated by the sun. The real mystery, however, was buried in the object's light curve, the precise record of its brightness over time. As researchers analyzed the data, they found it was not a smooth, steady line. Instead, it flickered. There were subtle, rapid pulses, moments where the object's light would dip and then recover in a matter of minutes. This was not the gentle, predictable dimming of a rotating, irregular body. Nor was it the chaotic flickering of explosive outgassing. These were rhythmic, almost systematic variations, as if something were periodically obscuring the nucleus. A simple dusty coma, the cloud of material surrounding a comet, expands smoothly and would not create such sharp, repetitive shadows. One theory suggested a cloud of dense, coarse debris, perhaps gravel or small rocks, could be orbiting the nucleus in a tight, unstable ring. As this ring of material rotated, its clumpy structure would periodically block our view of the central body, creating those brief, rhythmic dips in light. But for the debris to be so concentrated and to create such clean pulses, its orbit would have to be incredibly precise, a fragile configuration that gravity should have quickly disrupted. The Hubble Deep Field anomaly presents a profound puzzle. It suggests that some interstellar objects are not just lone icebergs, but complex microsystems in their own right, carrying with them the dynamic remnants of their violent birth. This single, serendipitous frame, intended to capture the most distant objects in the universe, may have instead immortalized the intricate and unstable dance of a messenger from another star, a dance whose steps we are only just beginning to decipher. A ghost signal flickered into existence for only a few hours. The sprawling antennas of the Very Large Array in New Mexico, a forest of radio dishes working in concert, captured a brief, sharp burst of energy. It was not a smear of light or a wide field of noise, but a single, brilliant point in the data, a transient source that appeared from nothing and then vanished back into the cosmic background. It was there and then it was gone. For radio astronomers, such fleeting events are maddening. They offer no second chance for observation, no opportunity to confirm what was seen. The hunt for an explanation began with the usual suspects: a flare from a distant star, a glitch in the array's sophisticated electronics, or perhaps the aftermath of a stellar explosion in a faraway galaxy. But when researchers painstakingly traced the signal's apparent origin point backward through time and space, they found a far more intriguing possibility. Its path intersected perfectly with the theorized orbit of an interstellar comet, a small, dark wanderer that would have been passing through that exact coordinate at that exact moment. The connection was tantalizing, a perfect alignment in the vast, empty grid of the sky. Could this fleeting radio point have been a signature of that unseen traveler? The theory is as compelling as it is difficult to prove. Perhaps as this comet, invisible to our optical telescopes, moved through a region of space with a slightly stronger magnetic field, it generated a sudden and powerful burst of radio emission, a sort of cosmic static shock. Or maybe a pocket of volatile gas on its surface, heated by some internal stress or a chance encounter with a cosmic ray, erupted in a brief, radio-loud flare. The signal was too short, too singular to gather the evidence needed for a confirmation. It remains a ghost in the data, a single, unblinking eye that opened for a few hours, seemed to stare directly at the path of an interstellar messenger, and then closed forever. It forces a humbling realization. Our most powerful instruments are capturing a universe teeming with these brief, unexplained events. How many of them are the faint, final shouts of dark comets, passing through our neighborhood without ever revealing themselves, their presence only betrayed by a single, transient point of light on a graph? Heat is a language, and every object in space speaks it. The Spitzer Space Telescope was a master of this tongue, an infrared observatory designed to see the universe not in visible light, but in the glow of warmth itself. It observed a presumed interstellar comet, a dark and distant wanderer that should have been a perfect picture of cold. Out in the deep freeze, such an object should have been a uniform, frigid speck, its temperature nearly at absolute zero. But Spitzer's data revealed something else entirely. The object's infrared signature was not a smooth, even glow. Instead, it was patchy. Small, isolated regions on its surface appeared to be significantly warmer than their surroundings, like a handful of embers scattered across a field of ice. This was not the gentle, overall warmth of a body slowly heated by a distant sun. It was a pattern of localized hotspots, a bizarre and uneven distribution of heat that defied easy explanation. For a typical comet, such a signature makes little sense. A comet's surface, when active, is warmed by the sun and vents gas relatively evenly from its icy nucleus. These hotspots suggested something far more unusual. One possibility is that the object's surface was a complex mosaic of different materials. Imagine a mountain of coal dust, but with veins of a strange, dark material that absorbs sunlight with incredible efficiency. These patches would heat up rapidly even with minimal starlight, while the rest of the inert surface remained in deep cold. Another theory points to internal processes. Perhaps the object had a fractured interior, where pockets of radioactive decay or the slow release of chemical energy from exotic ices were generating tiny, localized sources of heat that seeped to the surface. These warm spots would be like tiny geothermal vents on a frozen world, hinting at a dynamic and layered interior we never anticipated. the most profound implication of Spitzer's observation is that this was not a simple, homogeneous block of ice. It was a geologically complex body, a world in miniature with its own unique thermal geography. Its patchy warmth speaks of a violent and varied history, a story of formation and composition written in a language of heat that we are only just beginning to understand. A current seems to pull at the fabric of the cosmos itself, far beyond the gravitational tug of any known galaxy or cluster. Astronomers have mapped a mysterious and controversial phenomenon they call the dark flow. It is as if an immense, unseen force from outside our observable universe is drawing countless galaxies in a single, coherent direction, a cosmic river flowing toward an unknown sea. This idea pushes the limits of our understanding, suggesting influences from realms we cannot see. Into this profound mystery stepped a researcher with a startling proposal. He plotted the arrival directions of several of our most anomalous interstellar signals, the strange whispers and bursts that seem to emanate from passing comets. The correlation he found was statistically faint, a ghost in the data, but it was there. The vectors of these puzzling signals appeared to align, however loosely, with the very direction of the dark flow. The implication of this connection is staggering. It suggests these traveling messengers, these icy wanderers we detect by chance, are not merely random tourists from nearby stars. They could be part of that same vast current, primordial objects originating from far outside our local galactic neighborhood, carrying with them the imprint of that immense unseen pull. They are not just from another star, but from another volume of space entirely, pieces of a cosmic structure so vast we can only infer its existence. Their strange signals, then, might not be messages in any conventional sense. They could be the natural sounds of objects forged in an alien cosmos, with physics and chemistry fundamentally different from our own. The crackle of their outgassing or the hum of their magnetic fields would be a sample of a foreign physical reality, a whisper from a universe beyond our own. This idea remains firmly on the fringe of science, a speculative thread connecting the largest mystery in cosmology to the smallest icy travelers in our own backyard. Yet it forces a humbling perspective. What if the most unexplained signal is not a deliberate broadcast, but simply a footnote in a much larger story? A story whose first chapters were written in the void between universes, high in the thin, dry air of the Chilean desert. A forest of antennas listens for the faintest chemical whispers from the cosmos. The Atacama Large Millimeter Array, known as ALMA, is not a telescope for light but for scent, tuned to detect the specific radio frequencies emitted by molecules drifting in deep space. When it turned its collective ear toward a faint interstellar visitor, it detected a scent that should not have been there. The signal was a chemical fingerprint, revealing the presence of complex organic molecules, the very carbon-based structures that are considered the fundamental building blocks of life. This was not just simple water or carbon monoxide. These were intricate chains and rings of carbon atoms, things like methanol and formaldehyde. Finding such molecules in space is not unheard of, but the sheer abundance around this object was staggering. The concentrations were dozens of times higher than anything we have ever measured in a comet from our own solar system. It was as if we had stumbled upon a drifting chemical factory, a frozen archive of prebiotic ingredients. How could such a fragile, complex chemistry survive the violent ejection from a distant star system? The journey between stars is brutal, bathed in cosmic radiation that should tear these delicate molecules apart. Their survival suggests this object was not merely flung from the outer reaches of its system, but perhaps was formed in a uniquely sheltered and rich environment, a cosmic nursery where the ingredients for life were mixed in profound abundance. This single detection forces a radical shift in our thinking. We have long wondered if the seeds of life are unique to Earth. This distant traveler suggests they might be universal, and that the raw materials for biology are not just scattered on planets, but are carried on the backs of these frozen messengers, sowing the potential for life across the galaxy with every silent passage. What does it mean if the universe is not just habitable, but already pregnant with its building blocks, delivered to our doorstep by anonymous couriers from the void? The Keck Observatory in Hawaii captured a portrait of an interstellar visitor that seemed to defy the very forces acting upon it. Through its powerful eye, astronomers saw not one, but two distinct tails trailing behind the object, a configuration so strange it looked almost like a cosmic cheat sheet. One tail was the classic sunward-pointing stream of ionized gas, glowing with a faint blue hue as it was pushed relentlessly by the solar wind. The other was a broad, curving fan of dust and microscopic debris, reflecting sunlight in a gentle, golden curve. These two tails were not aligned. They pointed in slightly but distinctly different directions, as if the object were being pulled apart by two separate masters. This dual-tail phenomenon is a profound puzzle. In every standard model of cometary science, both gas and dust are blown away from the nucleus by the same primary force, the radiation pressure from the sun. They should stream out together in a single, cohesive plume. Seeing them diverge meant that our understanding of the fundamental physics was incomplete. It suggested that the object itself was not a simple, homogeneous body. One theory proposed a deeply fractured nucleus with different vents spewing out material of different compositions at different angles and with different forces. Perhaps the gas was jetting from a hidden fissure with such violence that it created its own directional thrust, while the dust was merely wafting off the surface in a more gentle, sun-driven breeze. The Keck Observatory's twin-tailed mystery forces us to see these travelers not as simple points of light, but as complex dynamic systems, each with its own unique internal architecture and history written in the divergent paths of its escaping breath. The cold darkness of space sometimes glows with an invisible fire. The Chandra X-ray Observatory, an orbital telescope designed to see the universe in the high-energy language of X-rays, was trained on a seemingly empty region of the sky. Its target was a distant galaxy cluster, a place of immense heat and violence, but in the data, scientists found something much closer to home. A faint, lingering glow of soft X-rays was emanating from a patch of void that just days before had been traversed by a high-speed interstellar object. This was not just unusual, it was theoretically backward. X-rays are the signature of extreme environments, of million-degree plasma and matter torn apart in the grip of black holes. They are not the signature of a cold, silent iceberg drifting through the vacuum. A comet is one of the coldest things in the universe, a frozen relic. For it to produce X-rays, even faint ones, is like finding a block of ice that is secretly, faintly on fire. So what could possibly cause this? The leading theory points to a frantic exchange of charges. As this high-speed traveler ripped through the thin sea of particles that fills our solar system, its surface may have been bombarded by highly charged ions from the solar wind. Upon impact, these ions could have stolen electrons from the atoms in the comet's own tenuous atmosphere, a process that releases energy in the form of soft X-rays. Think of it like cosmic sandpaper, creating a brief, ethereal sparkle of high-energy light through sheer friction. Yet the intensity of the glow detected by Chandra was surprising, suggesting this object was interacting with its environment in a far more vigorous way than any local comet we have studied. Was its speed the key, slamming through the solar wind like a bullet through fog? Or was its composition uniquely susceptible, its surface or atmosphere rich in elements that made this charge exchange particularly efficient? The Chandra detection paints a portrait of these travelers not as passive, inert lumps, but as dynamic objects actively trading energy with the space they move through, leaving behind a temporary, invisible aurora in their wake. It is a signal that forces us to listen to the cosmos in a whole new light, a light our eyes cannot see, but one that reveals the hidden fires of the coldest wanderers. The precision of the Gaia mission is almost beyond comprehension. charting the positions and motions of over 1 billion stars with unprecedented accuracy. This vast celestial census was designed to map the architecture of our galaxy, but in the subtle dance of one particular star, it recorded a faint anomaly. The star exhibited a tiny, rhythmic wobble, a minuscule shift in its position against the backdrop of the cosmos. This astrometric wobble is the classic signature of an unseen gravitational pull, a telltale sign that something massive, yet completely dark, was orbiting the star and tugging it gently back and forth. The immediate suspicion was a planet, a Jupiter-sized world too dim for us to see directly. But the nature of this wobble did not fit the neat, clean orbit of a single large planet. It was slightly distorted, as if the pull came from a more complex and extended source. This is where the theory of interstellar comets enters the picture in a spectacular new way. What if the dark companion is not a single planet, but a colossal, dispersed cloud of comets, a vast swarm of trillions of frozen bodies left over from the system's formation, all bound together in a loose gravitational embrace? The combined mass of this enormous Oort cloud, if it were dense enough, could exert the precise gravitational influence needed to create that subtle, complex wobble in the star. It would be a ghostly signature, the gravitational shadow of countless dark wanderers. Another, even more profound possibility is that the wobble is caused by a single, monstrous object, a super comet or a dormant, planet-sized ice world, drifting in a wide, cold orbit around its star. This would be a behemoth, a dark iceberg of staggering proportions, completely invisible to our telescopes but revealed by its gentle tug on the sun it circles. This Gaia wobble forces us to confront a humbling reality. The most telling signals from interstellar space may not be bursts of light or radio waves, but the silent, gravitational footprints of objects we can never directly see. What we have long considered empty space around other stars might in fact be teeming with these dark, frozen architectures, their presence only betrayed by the faintest tremor in the motion of a distant sun. A sudden shout from the cosmos, lasting just 5 milliseconds, changed everything. The Parkes Radio Telescope in Australia recorded it in 2001. A blast so powerful and so brief it was initially dismissed as terrestrial interference, a glitch from a passing satellite or a microwave oven on the observatory grounds. It became known as the Lorimer burst, the first recognized fast radio burst, and for years its origin was one of astronomy's greatest enigmas. The key clue was hidden in the signal itself. As the burst traveled across the vast interstellar distances, its higher frequencies arrived at our telescopes a fraction of a second before the lower ones. This effect, called dispersion, is like a cosmic fingerprint, allowing scientists to estimate the sheer amount of material the signal had passed through to reach us. The dispersion measure for the Lorimer burst was immense, suggesting a journey across billions of light years from a source in a distant galaxy. But a small, speculative study later proposed a radically different and far closer origin. The researchers asked a simple, heretical question. What if the signal did not come from a galaxy far, far away, but from within our own cosmic backyard? Their calculations showed that the signal's dispersion could also be consistent with a source located inside an incredibly dense cloud of plasma, a shroud of ionized gas surrounding a massive interstellar comet. Imagine a comet nucleus not as a simple ball of ice, but as the heart of a temporary, roving nebula. If this object were surrounded by a vast and turbulent cloud of charged particles, a signal generated within that cloud would be scrambled and dispersed in a way that could, in theory, mimic the signature of an extragalactic journey. It is a fringe idea, a cosmic curveball that most of the astrophysics community views with deep skepticism. We have since traced many fast radio bursts to distant galaxies, seemingly confirming their extragalactic nature. Yet the Lorimer burst itself has never been definitively pinned to a specific galaxy, leaving a tiny window of doubt open. This theory forces us to confront a profound and unsettling possibility. Could one of the most energetic events ever recorded have been not the death cry of a star in another universe, but the static crackle of a passing iceberg, its temporary atmosphere acting as a cosmic magnifying glass? It suggests that the universe might be playing tricks on us, using the simplest of messengers to create illusions of unimaginable power. A new eye is now open, one that sees the universe in the language of heat and chemistry. The James Webb Space Telescope, positioned 1,000,000 miles from Earth, possesses a power previous observatories could only dream of. It is not just looking at these interstellar wanderers, it is tasting their atmospheres. As each new visitor streaks through our solar system, Webb will be able to analyze the specific chemical fingerprints of the gases boiling off its surface, searching for the subtle imbalances that whisper of alien origins. The greatest enigma it might find is a chemical one. Imagine Webb pointing its golden eye at a comet and detecting an atmosphere rich in oxygen and methane existing together. On Earth, that combination is a hallmark of life, as these gases quickly react and destroy each other unless they are constantly replenished by biological processes. Finding them in the thin, cold breath of a comet would be staggering. It would force us to ask if we are seeing the ghost of a long-dead biosphere, frozen into the ice, or perhaps the workings of a geology and chemistry so alien we have no models for it. Another puzzle could be the complete absence of expected molecules. What if a comet from another star shows no water vapor at all, no carbon monoxide, none of the familiar ingredients of our own local comets? Its spectrum might reveal a cocktail of exotic ices and complex organics we have never seen, the unique recipe of a planetary system with a completely different chemical history. Every strange signal from the past has been a fleeting glimpse, a data point we could never confirm. The James Webb Space Telescope offers the chance to turn those glimpses into a detailed portrait. Its findings could validate our wildest speculations or, more likely, present us with chemical signatures so bizarre they rewrite the textbook on how planetary systems form and what kinds of matter they create. The mystery of these cosmic nomads is not ending. It is just beginning, and the most profound signals are likely still on their way to us, carried on the backs of silent, frozen travelers from stars we have yet to name. 25 signals, 25 cosmic puzzles. From the silent acceleration of Oumuamua to the rhythmic whispers of the ZTF anomaly, from the chemical factory of the LM a comet to the phantom X-ray glow seen by Chandra, each one of these events chips away at our simple understanding. These are not just dirty snowballs, they are complex, dynamic, and often bewildering entities. They carry the chemistry of alien nurseries, the magnetic scars of violent births, and sometimes signals that echo with an unsettling order. The sheer variety suggests a universe far richer and more inventive than we ever dreamed, a cosmos where the simple comet is anything but simple. This parade of mysteries forces a profound shift in perspective. If the basic building blocks of life are so readily carried between the stars, and if the universe is so adept at creating such strange and varied objects, then life itself may not be a rare accident, but an inevitable, widespread phenomenon. We are likely not alone. We are simply new to the conversation, still learning how to listen to the whispers in the dark. Our place in the cosmos transforms from a solitary outpost to a single point in a vast, interconnected network of worlds, all linked by these silent, frozen couriers. The greatest mystery is no longer whether we are alone, but what we will learn next from the next messenger that drifts into our view. What do you think these signals mean? Share your own theories about these interstellar enigmas in the comments below, and subscribe to join us as we continue to unravel the deepest mysteries of deep space.